Okay, Ryan Schul here. Welcome to my analytics channel. So in the project today, I decided to take a look at NYPD arrest data that originally comes from this link over here. I'm going to share it at the bottom of the Jupyter notebook. So I downloaded the data from here. I'm using a CSV file that is saved on my desktop. So if you want to copy and paste this code and follow along with me, you can certainly do that. I'll share all this code with you guys right when I post the video later today. And originally this comes from a broader data set. It says 311,682 data sets found. Okay, so that was the motivation for this today. So why would we even do this type of analysis? What's the motivation, right? To identify crime patterns and try to understand trends by borough, by precinct, things like this, to figure out which neighborhoods are more dangerous or more violence and which are less dangerous, to understand demographics of criminal activities or of criminals themselves, right? Monitor changes over time. Is the neighborhood getting better? Is it getting worse? We can do geospatial analysis where we're looking at longitude, latitude coordinates and trying to correlate that to crime frequency counts. We can certainly evaluate police performance, guide public safety, and try to enhance public safety, right? That would be one goal. Increase transparency and accountability of the officers and hopefully of the citizens of New York City as well. And then just build predictive models. I'm not going to do this in part one because when I started, the analysis grew bigger and bigger and bigger, and I realized this thing's getting pretty big, and I didn't want to drag it on and on, so I'm splitting it into two parts. So the first part will be like more of a fundamental statistical analysis, EDA, exploratory data analysis, things like that. And in part two, I'm going to build some predictive models and try to predict the frequencies and accounts of crimes going into the future. Now, it's next to impossible, if not totally impossible, to say, okay, a crime is going to occur on this date, at this time, at this spot, and have the police out there and intercept the criminal before they even commit the crime. I don't know if we're going to see that in our lifetime, right? But we can certainly look at trends and patterns over time and see if one neighborhood is underserved by the police and we have to shift some resources, some police resources to that neighborhood, or if one neighborhood really has no crime, basically no crime, and we don't need a large police presence. And again, we can shift resources to where they're needed most, right? So here's the data set. You can see, I thought this was funny, right at the end, they have a little underscore instead of just .csv. Usually you have the file name. They have the file name with an underscore .csv. So this is government data, and I'm not expecting it to be perfect. And when I look at it here, they actually have two underscores together. So usually you don't see that, right? This is government data. Usually that's how you would set this stuff up, but that's not how they do that, right? So I'm just going to follow the pattern. It looks like a mistake. Wait a second, what's going on there? Looks like a mistake in the pattern of the naming, the convention of the naming here, but we'll just go with it. Okay, so Control Enter. Okay, take a quick look at the. I already got it wrong. Okay, so I have to go to my desktop because they made a mistake in the way that they named the. Oh, I see it. It's that thing right. They made a mistake in the way that is not that thing. Okay, let's see if this works. Yeah, okay, here's the data frame. So you gotta love it. It's government data, right? And right off the bat, I'd be a little suspicious of the accuracy of this data, but that's what we're given, so that's what we're going to use. Okay, so we have the arrest key, arrest date, PD, CD, PD description. So I think this is some kind of, I don't know what CD means. I don't know. This is a description of the crime, I think. Offense description, law code, and we have a couple other features over here. So borough, arrest precinct, jurisdiction code, age group, male, female, and then race and X coordinate, Y coordinate, and then longitude, latitude. So there's the head, there's the tail. By default, we always get 5 records. If we want to see 100 or whatever, we would put 100 into that. Okay, and it's going to show us the first 100. So the first thing I want to do here is is plot some data and just visually see what this looks like. So if you look over here, let's go back to the data source again. It's government data, so I'm a little bit suspicious of the quality of the data. It says NYPD arrest data year to date. Okay, So it says it's accurate as of April 19th, 2025. Today is June 10th, 2025. So that is almost 2 months ago when the data was updated. But if you look closely over here in the data itself, we have month January, month February, month March, right? And then if you look close over here, March 31, 2025. So that's when the data actually cuts off. According to them, it goes up to April 19, 2025. And you would think they would have like a little bit more up-to-date data, like maybe it's a week behind or a couple weeks. In this case, it's almost 2 months. So again, government data, right, has nothing to do with me whatsoever. I thought it'd be a little bit more real time, but it just is not. And we'll just use what we've got here. I think it's decent. Could it be better? Absolutely. But you know the old saying, garbage in, garbage out. If you try to make predictions like we're going to do in part 2 of this analysis, if you have a bunch of mistakes in the data, the model can't learn accurately and it can't make predictions accurately. So I'll show you how to do it, and we'll definitely do it, and we'll get some good predictions. But the more refined the data is, the more up-to-date the data is, and just the better overall quality of the data, then the better the outcome is going to be, the better the predictions and more precise as well. Okay, so we have January, February, March. So just doing some very basic EDA right here. So these are the top 10 offenses. So we have assault and related offenses, petite larceny, dangerous drugs, felony assault, miscellaneous, penalty law, and robbery, rounding out the top 10. And for the least frequent counts of offenses, we have unlawful possession of a weapon on school, just one count in the first 3 months of 2025. Escape, just one count. I'm not sure exactly what that means. Homicide, negligent vehicle. Okay, admin codes. And then the most frequent of the bottom 10 here is harassment. And I thought this was kind of interesting too. Jostling. I'm not even sure what jostling is. Jostling. I have to look that up. I think I've heard this. I don't even know what this is. Jostling. Oh, push elbow or bump up. Oh, bump up against. Okay, maybe on the subway, somebody got an elbow in the ribs or in the face or something. So that's jostling. 13 counts in the first 3 months of 2025. Okay, so don't jostle people on the subway. I guess that's the takeaway there. So let's look by perpetrator race and perpetrator sex. Okay, that's fun to say. So American Indian, Alaska Native is the smallest. Unknown, I guess that just wasn't filled out. There's 221 that weren't even recorded correctly. 3454 for Asian Pacific Islanders. Black is certainly the biggest perpetrator here. So 27,000. Red is male and female is blue. Obviously, right? You can see the color scale on the right. We have Black, Hispanic, white, and white Hispanic over here. So now we know by race and by gender. So I think that's good insight right there. Bar chart by age group and by perpetrator race. Okay, so again, we're going to count the frequencies of the crimes committed by age group and by race. Okay, so the first time it was race and gender. Now it's age and race. So we can see Black really dominates all the age groups here, and we have 18, less than 18. We have to break down here. I like these plotly charts because you can zoom in and zoom out, right? So there's all the details. We have 567, white Hispanic. White is 113, Black Hispanic 269, Black 1387, and red is I think red is unknown. Oh no, Asian Pacific, and the total count would be almost 2,500. Okay, I don't see it total because everything gets broken down here into details, but this is another interesting perspective, right? So we had race and gender, now we have race and age. So clearly the 25 to 44 year group dominates here, right? Over 40,000 crimes. Or arrests, we're looking at arrest data. Now let's look at arrest by age and sex, okay? So we're getting all the different angles here. So age and sex, less than 18, 18 to 24, 25 to 44. We already knew that from before. And then it kind of dips down here. I guess people are getting too old to commit crimes at this point, and 65 and over. You don't have a whole lot. It looks like 1,339 or so. So maybe 1,140 almost. Okay, and if you look close at the details of the code here, I won't go into all the details here because the video would drag on and on. But the x is your horizontal axis, right? The y is the vertical axis, and all these Plotly's bars are very easy to work with, right? You can look this up, Plotly in Excel. Okay. Not Excel, sorry, in Jupyter Notebook, and you can go over to their main website. Oh, I got this dumb thing. Okay, I want to get Google. So this Bing is not quite as good as Google, not even close in my opinion. So this should be much better to get you to one of the main pages here for Jupyter. Okay. So I'm not going to go off on a big tangent here, but they do have excellent documentation for how all this stuff works. Okay, if you look at this close, basically, let's see if I can find some good examples here. You know, I think I saw one other deck back here. Let me go here, get me started. Okay, is this, or they just changed the site around since I was here last? All right, that's all right. Oh, that's okay. Not really what I was looking for. You know, I think they changed this pretty massively because the last time I came over here, it was a very different look and feel. Yeah, I'm not really seeing it. I'll give it one more shot here. Yeah, this is not what I was expecting to see. So that's really changed a lot. They used to do a good job with this. They explained exactly how all these work. So the x variable is right here, right? This is the horizontal, this is the y variable, so that's the vertical. We're looking at counts. We get the count over here, okay? So we're managing the data frame and doing a group by age group and perpetrator sex. Okay, so that gives us grouped age by sex. If you do a control F, oops, control F, and see the paste. So we just take this data frame, manipulate it a little bit using a group by and a count. We have a new data frame. The x variable is horizontal, the y is the counting, the color is the perpetrator sex, which comes from over here, and then we just assign a title, and this is called a stacked bar chart, and this is the height and the width of the chart. So it's really very basic, and you can use this same concept over and over and over, right? So that's how I got that chart. This is almost the same thing. I'm counting by age group and perpetrator race. I get this grouped age race, okay? So Control C, Control F, you can see that becomes a new variable data frame that we're working with. The X is horizontal, the Y is vertical, and we're assigning a color as perpetrator race. And if you look over here, almost exactly the same thing, perpetrator sex and race. So grouping by both features, we're counting all the occurrences here. And that becomes a new temporary data frame. Again, horizontal, here's the vertical, and this is the color. So you just follow that same pattern over and over and over, and you can create all kinds of very cool, very interesting charts that tell a quite rich story. So at this point, I want to do some clustering and take a look at basically an elbow, it's called an elbow curve for clustering, and this helps us determine the optimal number of clusters. So in this case, I think there's not really a good smooth fit between how all these clusters are broken out and how kind of they overlap and they intersect with each other. I didn't see any evidence of that. So I'm looping through 40 different iterations. Normally you go like 10, 12, 15, whatever it is, to try to get a good pattern for the bend in your elbow curve. This one just keeps going and going down after 42 times. There's really no bend. You should see like a slight movement down to the right, and then it bends at some point and starts to flatten out, and that the bend is the optimal number of clusters to use for your clustering over there, okay? So I don't know what the optimal is, and there's no real discernible pattern here. So if increasing the K just gives us a longer and longer, sharply diminishing return or diminishing plot right here, it's really not helpful. And I think it just fails to find the definitive boundaries of this cluster, right? You can't really derive that because there's some overlap here, there's some ambiguity, there's not a strong cluster structure that we can really extract from the data. So it just keeps going on and on. So I just picked 10 clusters to work with. I thought that was a good, after testing a couple different numbers, I thought that the map looks pretty good. So now I'm doing clustering based on latitude and longitude, right? And I want to look at where all of these crimes are occurring and then plot this on a plotly map. So, and then what happened to my clusters here? Oh, they're there. It's generating now. Okay. So it's a little bit slow, but you can see the distinction over here. So everything here is cluster 6. We go over the border here. This is cluster 0. Then we get down here. This is Upper East Side, Upper West Side. This is cluster 3. This is FIDI down here. Cluster 9 is Brooklyn. Cluster 3, this is my neighborhood over here, Long Island City. And you go out further and you'll have cluster, what is this over here? Cluster 4, cluster 8. Down here is Brooklyn, that's 2. Here's cluster 1, and Staten Island is cluster 5. So you can see just by the latitude and longitude coordinates where all the crimes are committed. So I think that's kind of interesting, but I think we need to do a little bit more analysis to do something really, really valid and very meaningful here. Okay, so I think these exercises are good, but it's just kind of scratching the surface. Really, we have to do a little bit deeper dive. So I want to continue with this concept of clustering and see if we can cluster based on the description of the offense, right? What kind of crime? Is it violent? Is it not violent? Is it drug use? Is it domestic use? And then the perpetrator's age, and then the age group that they belong to, right? Just to try to do a different type of clustering rather than longitude, latitude, which I think totally worked, and it's kind of interesting. But is this going to help us solve any crimes? Not at this point, right? So we have to go a little bit further with this. So we're going to use a concept called PCA, Principal Component Analysis, and try to take all this data that is kind of high dimensional and kind of complex and try to distill it down into 2 principal components. So PCA1 and PCA2, and you'll see a plot in just a minute. And then do all the clustering based just on these descriptors right here. So this is the offense description, right? The name of the crime, age group, and the race, right? So based on all of that, I want to see if I can create another lower dimensional data set, right? Because we have a lot of data here that we're looking at, and try to understand some type of pattern. That's where we're doing clustering, and we're using PCA to do the distillation or to break something from high dimensional space down into a low dimensional space. So we have our clusters. It's kind of working. You can see some overlap here. There's not a clear distinction between the age, the race, and the type of the crime. That's kind of what I suspected. I didn't know for sure. Over here, you see definite delineations, right? Because this is based on longitude and latitude. But down here, you don't see these kind of distinctions because everything is just all mixed up together, right? Like, it's not like somebody in a certain age group is going to commit a certain type of crime, but in another age group, they wouldn't, right? Everything is just blended together here, right? If it did work like that, then the PCA would help us tease that out, and we can see the distinction between these 3 different groups, between the type of crime, the age of the perpetrator, and the race of the perpetrator. But you can't use any of that to try to make these predictions, right? It just doesn't work out like that, right? So people of a certain age or a certain race are not committing certain types of crimes, and people in different ages and races are not committing those crimes, right? So it's just all over the place. So let me look at one more example here to plot the results of these same clusters. We're just going to look at a cluster centroid. So all these clusters are arranged in a certain pattern where there's a middle part that's called the centroid, or the center of the cluster, right? And all of the similar related data points that are homogeneous to that center, if they're pulled into that center, then they're grouped around that, right? So we can see the different centers here, and some of these seem to have just a few data points, right? So we had 10 clusters originally. It starts with 0 and goes up to 9 because Python is 0 based. So if you put in 10, it actually ends at 9. It doesn't go all the way to 10. But we can see the 10 clusters here, and then we can see the groupings of all the types of crime, the age group, and the perpetrator race. Okay, so we see it right here. We see this is assault, and the person was 45 to 64, and it was American Indian or Alaskan Native. Okay, so that's cluster 6. Oh, that was a specific person, but everybody that committed similar crimes, similar age, and similar type of crime goes into the same cluster, right? That's the point of doing clustering. So let's look at the geospatial analysis. Okay, and against like the same thing before, I'm creating the heat map based on longitude and latitude. Okay, and you see this pattern over and over in my code. You see it in Plotly all the time. So we create the custom data frame based on that data frame, which we feed in here. We feed this into the plot. We have the horizontal. This is latitude. The longitude goes on the y-axis, right? Whoops. Okay, we had a crash here. Let me get back. This computer's getting old, guys. We might have to remove it from this world pretty soon. Okay, so let's get back to where we were. Good time for a water break. Okay, maybe it's just too many things going on in the background too. Don't save it. Okay, so we're back. No. Okay, give it a minute. Give it a minute. This isn't even a huge data set, so I'm not sure why we saw that. Okay. I think we lost the kernel. I think that's what it was. Okay, so let's get back to our plotting. So there's the first clustering exercise. Here's the second. Then we have clustering with centroids printed in the middle. Okay, here we go. And then, okay, so we have our plot now. Same thing as before, we create a custom data frame. Here's the X variable, here's the Y variable. There's no Z because it's not a three-dimensional data frame, it's just two-dimensional. The radius is set to 10. I'm going to change that in a minute. It makes a huge difference. And the center for the whole plot is going to be this latitude and this longitude. This is kind of like representative of the middle of New York City with all the 5 boroughs. That's why I picked that. And we have the height and the width of the plot. And that's basically it, right? So very straightforward. But it looks like mustard has exploded over here, or like I don't know what's going on, right? It's not very useful. If you zoom in, you can see longitude, latitude, and you do have your zoom controls here, so it is pretty interactive. Right, you could get right down to the crime scene, right at the spot. So it is kind of useful, but when you're scrolled out, when you're zoomed out like that, it's not super helpful. So I'm going to create a slightly different perspective and use radius equals 1. So the radius is just the size of the latitude, longitude coordinate where the crime was reported, right? So if we have this big, long radius 10, everything kind of looks like a mustard bottle has exploded, right? When we zoom out. And that is not going to be super helpful for us to do some type of analysis, right? But if we have our radius set to 1, it's going to be much more definitive of where the crime scene is, because the size of the circle is going to be much smaller, and we can just zoom in and see exactly where the crime occurred. So if we go down here, let's go down to the FIDI, just pick this just randomly, okay, and we'll see a couple crime scenes over here. So I can even zoom in a little bit more to get more detail, right? So there was a couple of crimes over here. This is, I have to go in even more to see it now. Okay, William Street was one. There's one right here. On Platt Street, we go over here, see another, Fulton Street, and another on Broadway. Okay, so it helps us get some more analysis or more insight into where crimes have occurred all over New York City, the demographics of the perpetrators, ages, genders, and things like that. So that's just part 1. I'm going to move on to part 2 and record the next video in a couple moments. I'll post them back to back later today. You should take a look at that. And remember, part 2 is going to be just taking this up and leveling it up so we can start to train some ML algos and make predictions into the future, the counts and the frequencies and the areas where crimes are going to occur. Now, again, I don't believe you can, at this point in time, you can say on this date at this time, such and such a person is going to commit a certain specific type of crime. We don't have that kind of knowledge, right? But I think we can generally say, this is a high crime area, very violent, prone to violence, and these are the types of crimes that occur here over and over, and staff the police according to that. And if there's neighborhoods of very low crimes, and we'll see that in just a bit in part 2, we can understaff the area. We just don't need the We just don't need the bodies there. If there's one crime committed in 3 months, we can have maybe one cop patrolling the area or two together. I think they always go out together, right? And maybe sometimes none. Maybe in the middle of the day, you don't need any police presence if you have one crime and a 3-month time span, right? But if you have 300 plus crimes, I'm going to show you in part 2, there's hundreds and hundreds of crimes committed in the same 3 months. That's probably where you have to staff up your resources. Okay. So I'm going to wrap it up right here. This is the end of part 1. I'm going to get started in part 2, and I'll post both a little bit later today. You can check those out. Okay. Thanks for your time, and I will see you soon. Bye.